All right, so today we are going to start off talking about inequalities. We're going to start off talking about some pretty basic ones. So if you look right at your packet, the first one that we should see is x plus 4 is greater than 10. Okay, so we're going to start off with these inequalities, and they're just going to be like equations. So normally if we had an equation x plus 4 is equal to 10, we would get x alone by subtracting 4. So we're going to subtract 4 on both sides, and so we're going to get x is greater than 6. So what that means is any number that is bigger than 6, when we plug this into that inequality, we'll get a true statement. So for example, if we want to check our answer, numbers that are bigger than 6, whole numbers are 7, 8, 9, 10. So if I were to plug 7 into here, I would get 7 plus 4 is greater than 10. So I'd get 11 is greater than 10. So is that true? Is 11 bigger than 10? Absolutely. Okay, so the next part is just being able to sketch a graph of a number line. So on your paper, you have a nice graph, but here's my makeshift example. So we have 0 here, 1, 2, 3, 4, 5, 6, and here are my negative numbers. So we're saying that this is true where x is greater than 6. So I go over to 1, 2, 3, 4, 5, 6, which is right here. And I'm going to put my circle. And so since it is not including 6, I know that I don't need to count it. And we're talking about all numbers that are greater than 6. So this way. So here's my graph, and it includes 6, 7, 8, 9, 10, 11, 12, 13, all the way up there, and then also those small numbers in between. Okay, so that's our first example. All right, so our second example, if we look at our paper, it looks just about the same, right? So it says that we have x, sorry team, hold on. It says we have x plus 4 is greater than or equal to 10. So the only difference here is that we have this greater than or equal to sign instead of just the greater than sign. So we already knew that we're going to subtract 4 from both sides. So we get x is greater than or equal to 6. So this again means that all numbers will work bigger than 6, but also including 6. So we could see that because if we were to plug in 6, we would get 6 plus 4 is greater than or equal to 10. So you get 10 is greater than or equal to 10. So is that true that 10 is greater than or equal to 10? Yes, it absolutely is, because 10 equals 10. Okay, so again, we would want to create a number line. I'll make this one a little bit bigger because my last one was not very good. If we have 0 here, 1, 2, 3, 4, 5, 6 is right here, 7, 8, 9, 10. So we're going to put our circle there, and we know it's going to be all of these numbers here. So our arrow is going this way. But the difference here is we're going to color in. We're going to color in this one because we can use 6. Okay? So the only difference there is just being able to fill in that circle correctly on the graph. Okay, so our next example is where we have 2x. Oh, it's doing this every time, sorry. We have 2x is less than 10. So normally if we were just to solve the equation 2x equals 10, we know we would just divide by 2 because that's the opposite of multiplying by 2. So I'm dividing by 2, I'm dividing by 2, and we get x is less than 5. Okay, so we know here that any number where x is less than 5 is going to work. So if I want to sketch this graph right here, we have 0, 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, all those other ones. So it's x is less than 5. So that's all these right here. Okay, we know it's open because we're not including 5. So numbers that will work for this equation are 4, 3, 2, 1, 0, etc., 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 all the negative numbers. Okay, so we could choose that. So let's choose any number that is along here. So maybe negative 4. That's all the way over here. So 2 times negative 4 is less than 10. So it says negative 8 is less than 10. So is that a true statement? Is negative 8 less than 10? Absolutely. So we check our answer. We know that this is right. Our answer is right here. And our number line is right here. Okay. So we also have negative 2x is less than 10. Okay, so if we're going to do this, we know that just like any equation we would solve, in order to get rid of this negative 2, we're going to divide it by negative 2 because it's multiplying, it's the opposite. And so we get x is less than negative 5. Okay, so just like any other time, we have our number line. 0 here, negative 1, 2, 3, 4, 5. It's negative 5 here. And we're saying that x has to be smaller than negative 5. So let's go ahead and let's plug in some answers just to see if that works. Okay, so a number that's smaller than negative 5, say negative 6, we're going to plug that in. So negative 2, just get a different color here, times negative 6, and we're going back to black, is less than 10. So we're going to get 12 is less than 10. So is that a true statement? Is 12 less than 10? Absolutely not. It is not. So that means that this negative 6 here, that's not working for us, okay? So that's going to be a rule for us. What we need to do anytime we multiply or divide by a negative is we actually need to switch this sign. So my correct answer is going to be the one I do in purple here. So since I'm dividing by a negative, I'm going to switch this sign. So right now it's currently a less than. We're going to make it a greater than. So it's going to actually turn this answer into x is greater than negative 5. So anytime you divide or multiply by a negative sign, you need to switch this sign. So basically the only thing is like, it's like we're dividing this by a negative, we're dividing this by a negative. So it switches it, divided this by a negative, okay? So we have x is greater than negative 5. So I'm going to graph that here. We know that all the numbers bigger than negative 5 are over here, and we know we're not going to fill in that circle because we don't have an or equal to sign at the bottom. So again, our rule is anytime we multiply or divide by a negative, we got to switch the sign. Okay, so we have a few more examples, and then we're going to be all done. So our next example says x over 5 is greater than or equal to negative 2. Okay, so I wanted to include these ones in here because people always get kind of just like naturally tripped up with these. But this is saying we're dividing by 5, and the opposite of dividing by 5 means that we are going to multiply both sides by 5. We're going to multiply both sides by 5 here. I'm going to just change my color so you can see. So I'm multiplying this by 5, multiplying this by 5. So these guys cancel each other out. So we have x is greater than or equal to negative 2 times 5 is negative 10. So what we're saying is that any x value that's greater than or equal to negative 10 is going to work. So we can check our answer always by picking a number that's bigger than negative 10. So a number that's bigger than negative 10 might be negative 9. It also might be things like 0, 1, 2, 3, 4, 5. So I'm going to choose maybe the number 0. So 0 divided by 5, is that less than or equal to negative 2? So I'm just plugging that in here. So 0 divided by 5 is 0. 0 is greater than or equal to negative 2. Absolutely. Works out. Okay? So if I want to graph it, I'm going to draw my number line, although you guys have number lines there for you. So here's 0, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here. I'm going to fill it in because it has that or equal to sign. And then I'm just going to draw my arrow. So it's a little bit easier when you're not on the computer to draw nice straight lines. Okay. So we just have one last question and we're all done. Okay. So if we look, our last question says negative 3x over 4 is less than or equal to 2. Okay, so when we do a problem like this, we don't want to be scared by fractions. They're not that scary. So in order to, so this right here, x is being multiplied by negative 3/4. So the opposite of that is going to be to divide by 3/4, which is the same thing as just by multiplying by the reciprocal, which is negative 4/3. So we're going to multiply both sides by negative 4/3. Multiply both sides by negative 4/3. Okay, so that allows these guys to cancel out. So we're left with x. And then remember, we're multiplying by a negative. So that means that we need to switch this sign. So this says less than or equal to. We need to make it say greater than or equal to. Okay? And then lastly, we have 2 times negative 4/3. Sometimes people hate fractions, but it's not that scary. So we have 2 times negative 4/3. When we multiply fractions, we're just multiplying the top and by the top and the bottom by the bottom. So you can think about how this really has a 1 underneath it. So 2 times negative 4 is negative 8, and 1 times 3 is 3. So what this says is x must be bigger or equal to negative 8/3. We're going to plot that on our number line. So we know we have 0, negative 1, negative 2, negative 3, etc., etc., etc. So when we think about how big this number is, if you don't know, you can always put in a calculator. So you can do 8 divided by 3, and if you were to do that, I believe you'd get negative 2.66666666, etc., which we know is between negative 2 and negative 3, a little bit closer to negative 3. Okay, I'm going to fill it in because it has that or equal to sign there. And then I'm going to go ahead and I'm going to draw an arrow because it's graphing all of this part here. And we can always check our answer. So we pick a number that's greater than that. 0 is always an easy number to pick. So I'm going to choose 0. So if I plug in 0 into my original equation, that one that's in black, we get negative 3 times 0 divided by 4 is less than or equal to 2. So we know that 0 times anything is 0. So is 0 less than or equal to 2? Absolutely. So we know it works. Okay, we did all the examples in our packet, so we are done.